on the premise and going to the cloud. And the requirements for doing that is, okay, we need this abstraction, and it's going to help us to fight this heterogeneity and the cloud vendor independency. So the differences between different providers. We have some automation that is going to help us to fight these problems of the difference between different providers, the unavailability problems, so you can farm more instances or more services when things go bad with one provider and go to another and so on. And with this variation of cloud performance, we can, instead of trying to say, okay, we are abstract, we are going to model the differences between different cloud providers. And then we can adapt the model to make sure we cope with these differences. I'm going to go into more details after, but the idea is that in MODAClouds we have an approach that allows us to fight this problem. So we have a model that's say organized in different levels of abstractions, and then we go from the more abstracted level to the less abstract level. And then the idea is that in the most abstract level, what we call the code computation dependent model, you model your application in a way that's independent even from the cloud. So you say, what are the services that I need to make my application run, that I need to provide to my users? How am I going to connect the services? And what are the QoS constraints they need to provide? So this is very, very abstract. What can you do with these things? At the next level, you start saying, okay, imagine these things on the cloud. So which service can I take and reuse something on the cloud to provide it? So I need to send an email, so I don't need to implement a new email service. I take it from the cloud. And the database. So I'm not going to implement in the database. I will take it to the cloud and implement it. So either I'm going to get less abstract and add more details to your model, to how we are going to provide the service in the cloud. And then you go to the cloud to provide a specific model. So when I have an application, I need a database, I need an email server, I have service A, service B, that's the way they're connected. But what if I want to deploy this thing on Amazon? What if I want to deploy them on other cloud providers? So what's going to change? And is at this level that we're going to say what's changed from deploying this application in one cloud to deploying the application in the other cloud. So the way you configure your application is going to change. The way you send your credentials to the cloud is going to change. The way you need to scale your application is going to change. All these things are going to be more at this level. At this point, I just wanted to show the models of our case study. How much time do we have? 30 minutes. So I should do it in 5 minutes. But the idea is showing that how this three levels approach is applied to our case study, to our constellation. So he's going to get a little bit more technical, but the idea is showing that we realize this application constellation, this service, by having an administration service. Just to make it precise, this is the computation independent layer of the constellation. So we're not talking about cloud, we're talking about services. So we need a service that provides administration. I'm going to administrate who are my users, what are the projects, who can use this project, who can use the other project, where are the models, and all these bureaucratic things. I need a service that's I call administration database. That's going to say, okay, how can I store this data? Then I have this service to say, okay, you need to create a new project cloud. So how can I instantiate something on the cloud? Then we have two kinds of services. There's the constellation SVN agent. It says, okay, I need to provide an SVN model on the cloud. How am I going to provide that to the cloud? I have a constellation HTTP agent. So how can I provide HTTP model on the cloud? So at this point, we model the services that we need to provide our application constellation. And then the client of this application must be modelable. In the case of these the models, so model is going to come to this agent and say, hey, give me this model. Go to the HTTP agent and say, hey, give me this HTTP fragment. And in the case of the web service, it's going to be both the user or modeling. So the user, the administration is going to say, okay, create a new project, create a new model fragment, and so on. And the modeler is going to say, hey, give me the list of projects this user is able to connect to. At this point, we have a high-level view of the application. Then, and I'm not going to show it now because it's going to be detailed in the other parts of the tutorial. We have the CPIM model. That's okay. Let's take this high-level map of my application and see if I say it's going to be on the cloud. How am I going to provide this kind of service on the cloud, for example? What kinds of VM instances I need? What I need to install in one instance and another one. I'm not going to give the details of this now because we're going to see more details in the next presentation. Just to finish, that's the design flow of MODAClouds. So the idea is that there are different tools that share parts of this single model, and then there's a bridge to the runtime. That means that you have this single model that describes your application, how you deploy it, the behavioral application, and then there's a returning environment that's going to deploy it, that's going to adapt it to the changes that arrive and so on. In the tutorial, I'm going to talk about the design part of MODAClouds, and I'm going to focus on these three tools. So the functional model environment, that's what I showed in Millennium. Space for Cloud Inline, this is the tool for analyzing the quality of service of the application. And we're going to talk about it tomorrow. And CloudML, that's the next point of this presentation. That's the tool that's going to deploy your application to the cloud, and it's going to effectively create this bridge between design time and runtime. So now I leave the floor to Nicholas from Syntef, who's going to talk about how you take these abstractions and push them to the cloud.
Hi, so yes, I will have two main parts in my presentation. One more about model-driven design of cloud application, and then I will go more in detail about cloud event. So tool for the deployment and provisioning of resources on the cloud and deployment of application on these resources. So the first part, I think it will be brief, and I said Danilo and Marcos have already presented quite some challenge related to the model-driven design of cloud application. So one of the challenges that we have already been discussing is that when you are trying to manage and design cloud application, you have to deal with many files, with many tools, with many concepts, probably many concepts which are at several levels of abstraction, for instance, depending on the type of cloud offering you are planning to use, like platform as a service or infrastructure as a service. And so this is already quite difficult to manage, and this is already difficult to provide models and languages which allow you to deal with all these concepts and all these tools. And in addition, most of the time, these tools and this abstraction, these concepts are already provider dependent, which then link to this issue that we have been discussing about vendor locking. So an approach that has been applied and which is used in the MODACloud project and which has been applied in many other projects like the Remix project, Passage, and Artist, for instance, are using this approach. It's basically an approach which is inspired by the model-driven architecture, and it's proposed, as already presented by Marco, so I will be fast, 3 levels of abstraction, cloud computational independent model, your model without any concept related to the cloud. You can use these models at this level to generate automatically or semi-automatically models at the CPIM levels, cloud provider independent models, so model which involve cloud-related concept, but in provider-independent way. And then this cloud provider-independent model can be used to generate, or semi-automatically generate, 1 to several cloud provider-specific models. So models which are involve concepts related to cloud, but these concepts this time are not provider-specific. So you're targeting one provider. So this is one of the challenges, and another main challenge that when you are trying to manage cloud application and design cloud application, often these activities involve many activities basically which themselves involve many domain of expertises. And domain of expertises like deployment, managing quality of services, monitoring, scalability, and so on. And a big challenge here is how can we write one model which is generic enough to provide solution for dealing with all these activities, but which provide concepts which are specific enough so that each domain expert can reuse his knowledge. This is very difficult, this is almost impossible, so then an approach to deal with this is rather than building one build model, one build language, we prefer to define a set of models or a set of small language, each of them being very specific, targeting a very specific domain. So then we can talk about domain-specific language or domain-specific model. And this is basically the approach that has been applied in MODACloud. So basically MODACloud ML, the MODACloud modeling language, is composed of a set of models at the various level of abstraction. So we cannot do it for you. And so at the CCIM level, we have models such as domains, which target domains such as describing the architecture of your application, describing the type of data that your application is going to use, the usage of your application, and so on. This can be used to generate models about how to deploy your application, how to still model your data, but this time including cloud-related concepts, monitoring rules, and so on. And we have exactly the same domains related as the cloud provider-specific model. So this way, these are domain experts can really focus on their model, can use their specific language or their specific model, and really fully exploit their knowledge. So now I'm going to discuss a bit more in detail one of this language, which is CloudML. So CloudML is basically a language, as I said, to describe the provisioning of cloud resources and the deployment of resources of your application on these cloud resources. So CloudML has been developed as a collaborative work between several projects. So it has been initiated in the Remix project, which is now over, and it's now ongoing work done in collaboration with MODAClouds and Passage. And to put it in a bigger picture, actually CloudML is part of what we call CloudMF, the Cloud Modeling Framework. And CloudMF is composed of two main components. One component which is a modeling environment with a tool-supported domain-specific modeling language. This language is CloudML. And another main component which is a model at runtime environment for enacting the provisioning and deployment of application on cloud resources on the basis of what has been specified by the first component. So now I'm going to present first the modeling environment and then the models at runtime environment. So what are the objectives of the modeling environment of CloudML? So basically it's to specify the deployment of multi-cloud application including PaaS and IaaS, perform the actual deployment of your multi-cloud application based on the specifications that have been done using CloudML. Dynamically deploy, adapt the deployments that have already been enacted by the engine so that you can at runtime change your deployment, change the topology of your deployment, modify the deployment of your application.